What's happening? Welcome back, welcome back. Today you are here to learn about vitamin D. So as with the previous presentations, you're here to see a deeper dive on the vitamin. We're going to go below the top layer of the information, see what we could learn, what would be applicable to the average person in order to optimize their health as efficiently as possible. We are trying to reduce and minimize the complicated sciencey side of it, but yet learn what we need to learn in order to understand what we need to know so that we can progress in our health journey. So, with that being said, what do we need to know about vitamin D? So, as with the other fat soluble vitamins, vitamin A, vitamin E, and vitamin K, vitamin D is also a fat soluble vitamin. Unlike those vitamins, though, we are not going to be able to get an adequate amount of vitamin D through our dietary intake, through the foods we eat. So, where we're going to get majority of our vitamin D is going to be either through supplementation or through sun exposure. But before we get to that, what we want to know is that vitamin D receptors are in almost every cell in the body. While commonly referred to as vitamin, it acts more like a hormone within the body. So vitamin D is stored within your fat cells so that it can be utilized when you need it. This doesn't necessarily mean that if you're fat, you have a large storage of vitamin D. It just means that when you come from climates that have all four seasons, including winter, when you're going through the winter months, you're utilizing vitamin D storage that's being stored in the fat cells. In the summertime, you are replenishing vitamin D and storing in the fat cells to be used in the winter months. So, what we need to know about vitamin D in regards to the sun is that even if you are getting sun exposure, like we learned in the cholesterol video, you still need other things to work in synergy in order for us to be able to convert the vitamin D that's coming from the sun and turn it into something that can be utilized by the body. So even when you get the sun, like we said, the sun hits your skin, there's a chemical combination that occurs between the sun, the organ of your skin, cholesterol, and then it goes through a conversion in the liver and the kidneys, and then it becomes vitamin D. So this means to us that if you have liver damage, kidney damage, a fatty liver, chances are that you're struggling to absorb vitamin D or that you may have a deficiency in this. So if that's you, then this is something you may want to get checked, your vitamin D levels. So the same thing applies to if you have low cholesterol. If you're taking statins, a cholesterol blocking medication, then most likely you will not have enough vitamin D either because you're blocking the cholesterol that's needed in order to synthesize and utilize the vitamin D that's from the sun. So when we look here at this article, you can see here in this study, Science Direct Hormone Precursors. So we can see the hormone precursor vitamin D can be obtained from the diet or synthesized from deochlorinate in the skin in a UV light reaction. Vitamin D then circulates to the liver where it's converted to 25 hydro vitamin D3. The major circulating form that is the final step in the production of the hormonal form occurs mainly but not exclusively in the kidney. All right, so that's just following up on what we were saying about those organs needing to be involved in that process. The other thing we can touch on here as well is this other article we looked at in the cholesterol video is that, however, sunlight is the best natural source of vitamin D3. The UV rays from sunlight convert cholesterol in your body, in your skin, into vitamin D3. Before your body can use dietary vitamin D, it must be activated through a series of steps. First, the liver converts it. This is the form is measured in blood tests. Later, the storage form is converted by the kidneys to the active form of vitamin D that can be used by the body. So that's just reiterating what we were just touching on there. So the next thing I want to touch on is the relationship between calcium and vitamin D. So like we were speaking about in the vitamin K video, we know that there's a direct correlation between vitamin D and vitamin K in regards to calcium metabolism. So we know that vitamin D directs where the calcium goes, but in order to remove the excess calcium from within the body, we need the vitamin D to mobilize it, but then we need the vitamin K2 to transport it out. So if you're deficient in either of these vitamins, you would logically hypothesize that you would be more likely to have a buildup of calcium, which would then increase your chances of having an issue with heart disease because you're lacking the vitamin D and the vitamin K that's needed to manage and deal with this excess calcium. So it's important to make sure you're getting enough vitamin D, not just vitamin K. The other thing to mention is that joint pain can be due to inflammation, but it can also be due to a buildup of calcium in the joints. So if you suffer from really bad joint pain in your knees, elbows, things of that nature, vitamin D and K2 combination will also assist through the anti-inflammatory pathway, but also if calcium is an issue, it will assist in that way as well. So the main issue here is that many people have calcium in their diet, but they're lacking vitamin A, vitamin D, and vitamin K. So if you have too much calcium circulating in your system, but you don't have enough vitamin D to absorb it, or vitamin K to metabolize it into the bones, then taking in that much calcium to your diet is not a good idea, right? Because you don't have what you need in order to deal with what you're taking in. So it would no longer be beneficial to you. We need these vitamins working in synergy. We can't just have an immense amount of vitamin D and then have good cholesterol levels, but then have no K2 in the diet and have no vitamin A. That's not going to allow us to optimize our health. So that's a main reason why calcification of the arteries, why calcium buildup, to me, it seems like a much greater issue than the LDL cholesterol, because what we need to deal with this calcium, most people on the standard American diet are lacking those vitamins. So you could then look and say like, well, are most people on the standard American diet taking in calcium? And they are, right? So if you're taking in that much calcium, but you're not able to metabolize it and you're not able to transport it, then that would technically, logically correlate to calcification of the arteries, leading to more likely the possibility of the issue being that in regards to heart disease than LDL cholesterol. But this is just our hypothesis. The main thing we want to determine is that when we are taking in calcium, we have vitamin A, we have vitamin D, and we have vitamin K, so that we don't have to have a concern with it. All right? So what we want to see now here is vitamin D and K work as a team. So when it comes to calcium metabolism, vitamin D and K work together, both play important roles. One of the main functions of vitamin D is to maintain adequate calcium levels in the blood. There are two ways in which vitamin D can achieve this: improving calcium absorption. It enhances the absorption of calcium from the food you eat, taking calcium to the bones. When you don't consume enough calcium, vitamin D maintains its blood levels by drawing on the body's main calcium supply, your bones. Maintaining adequate blood levels of calcium is essential. While calcium is best known for its role in bone health, it has many other vital functions in the body. So I just wanted to kind of touch on the synergy between them and how they work together in that sense, right? The other thing here, calcium builds up in the arteries around your heart is a huge risk factor for heart disease, which we were just talking about, calcification of the arteries. Anything that can reduce this calcium buildup may help prevent heart disease. Vitamin K is believed to help by preventing calcium from being deposited in your arteries. In one study spanning 7 to 10 years, people with the highest intake of vitamin K2 were 52% less likely to develop arterial calcification and had a 50% lower risk of dying from heart disease. Another study in 16,057 women found that participants with the highest intake of vitamin K2 had a much lower risk of heart disease. For every 10 mcgs of K2 they consumed per day, heart disease risk was reduced by 9%. So we need vitamin D and vitamin K2 in order to deal with this calcification of the arteries, right? Which is so important. You can also see here, vitamin K activates proteins that play a role in blood clotting, calcium metabolism, and heart health. One of the most important functions is to regulate calcium deposition. In other words, it promotes the calcification of bones and prevents the calcification of blood vessels and kidneys. So we need not just vitamin K, but we need vitamin D, because if we're taking in calcium through the diet, but we don't have enough vitamin D, then we can't utilize what the purpose would be of K2, right? Because we're not even absorbing it. So before we could utilize it and take what we need out of the benefits from ingesting calcium or taking in calcium from the diet, the vitamin D is going to allow us to first take it and then say like, okay, I can do something with this. But then we need the K in order to move it, right? So these things work in synergy together. We can't just have enough K and not have enough D. We can't just have enough D and not have enough K. Without an adequate amount of all the fat-soluble vitamins, the health benefits that are synergistic are not going to occur properly. We're not going to be able to optimize our health if we don't look at all of the fat soluble vitamins and make sure that we're getting an adequate amount of each of them, not just focusing on one of them, such as, oh, let me get enough sun. But just because I'm getting enough sun and I'm getting enough vitamin D, I don't have enough cholesterol, so now I'm not even getting the benefits of the sun, right? If I have enough cholesterol and I'm getting enough sun, but I don't have any vitamin K2 in my diet, now I'm giving myself the chance that I'm gonna have a buildup of calcium in my arteries, and I'm not gonna be able to do anything with that buildup. I'm not gonna be able to mobilize it and transport it out because I don't have any K. So it's not just about looking at one. Like, these things work together. So when you make a video, or when I do a deep dive on one of the vitamins, I end up having to kind of tie it in together with the other ones, how they correlate. So another thing that we want to touch on with vitamin D is that the relationship that it has with magnesium. So in order for you to absorb vitamin D, you need magnesium. So we just talked about cholesterol, we talked about the liver and the kidneys needing to be involved, and now we're referring to magnesium needing to be involved. So these things are not just as simple as take off your shirt and go stand in the sun and have a terrible diet and you'll get vitamin D. But when we look at magnesium and vitamin D, the relationship between them, we can see that magnesium assists in the activation of vitamin D in the liver and the kidneys. So vitamin D is dependent on magnesium. So if you're deficient in magnesium, you can be supplementing vitamin D or getting lots of sun, but you need magnesium as well as cholesterol to synthesize it. So you could have cholesterol, you could have sun, you could be supplementing the vitamin D, but no magnesium, no vitamin D, all right? So this is why we have to do these deep dives. This is why we have to look beyond just the top layer of the information to see what we need to know in order to optimize our health. Because I could be saying, like, okay, well, my cholesterol is good. I added vitamin K2 foods into my diet, right? I'm getting outside in the sun, or I'm supplementing vitamin D, but you have no magnesium, right? So then now you have to be like, oh, I'm not even being able to optimize this process because the magnesium I'm getting through my diet is so minimal. It's almost indistinguishable. It's almost zero. So this process is now still not optimized. So that's why when we look at this, we can see role of magnesium in vitamin D activation and function. Nutrients usually act in coordinated manner in the body. Intestinal absorption and subsequent metabolism of a particular nutrient to a certain extent is dependent on the availability of the other nutrient. Magnesium and vitamin D are two essential nutrients that are necessary for the physiological functions of various organs. Magnesium assists in the activation of vitamin D, which helps regulate calcium and phosphate to influence the growth and maintenance of bones. All of the enzymes that metabolize vitamin D seem to require magnesium, which act as a cofactor in the enzymatic reactions in the liver and the kidneys. Deficiency in either of these nutrients is reported to be associated with various disorders, such as skeletal deformities, cardiovascular diseases, and metabolic syndrome. It is therefore essential to ensure that the recommended amount of magnesium is consumed to obtain the optimal benefits of vitamin D. So we know that vitamin D seems to require magnesium, which acts as a cofactor in the enzymatic reactions in the liver and the kidney. We know that we need magnesium in order to have adequate vitamin D. We need adequate vitamin D in order to have adequate magnesium. These two work in tandem together as well. So not only do we see magnesium as a mineral in play here with vitamin D, we also can see calcium and phosphate homeostasis to influence the growth and maintenance of bones. So it plays a role in phosphate as well. And what else I want to show you is zinc here. So we can see zinc and its role in vitamin D function. Zinc is an essential mineral with an important relationship with vitamin D. Studies have found that reduced blood zinc levels could predict vitamin D deficiencies in adolescent girls, while zinc supplementation increased vitamin D levels in post-menopausal women. What I want to show you here is that zinc also acts as a cofactor for vitamin D functions, as the transcriptional activity of vitamin D dependent genes relies on zinc to exert pleiotropic functions, including mineral ion regulation. Vitamin D could also induce zinc transporters to regulate zinc homeostasis. Together, zinc and vitamin D Together, zinc and vitamin D in adequate concentrations help maintain a healthy musculoskeletal system and beyond. However, deficiency in either of these nutrients can result in various disorders affecting almost all bodily systems. This brief article will focus on the role of zinc and vitamin D functions. It says here, vitamin D is important for the regulation of phosphate and calcium, which are needed for optimal bone health. Vitamin D has many cofactors that are required to allow vitamin D activation to exert its functions in bone health and immunity. These cofactors, including zinc, are used as a necessary element in vitamin D functionality. So it has many cofactors that are required to allow vitamin D activation, and zinc is one of these cofactors that are included, right? So we know that now. We spoke about cholesterol being important. We spoke about the sun. We spoke about magnesium. We spoke about vitamin K2. We spoke about the healthy liver and the kidneys. And we also need to have adequate levels of zinc in order for these processes to occur efficiently. Zinc is essential for numerous biological processes, including cellular apoptosis, immune function, brain maturation and development, taste and smell regulation, skin and mucosal integrity, and metabolic function. It is used as a signaling ion to regulate gene expression, protein synthesis, DNA synthesis, and cell division. Though zinc has many other important functions not related to vitamin D, the focus on this article will be on the potential interactions between zinc and vitamin D and its concurrent effects on the vitamin D dependent gene activity. This article will also explain why adequate amounts of zinc is needed for vitamin D regulation and functions. So without going through the whole thing and dragging it on, we can clearly see that zinc also plays an important role in the cofactor of optimizing the bodily regulations that vitamin D is involved with. So the last thing I want to touch on before we talk about dosages and supplementation, how much do we need, I want to talk about the immune system and inflammation. So vitamin D, it's probably its main or largest or most important, however you would like to refer to it, function would be its role in the immune system. So especially with everything that's been going on the last few years with viruses and infections, looking at things that are important to the immune system are more and more important, we should say, now more than ever, right? Obviously it was important before, but now people are kind of putting more attention on it, and they're seeing it as something that they'd want to focus more on. Like, I want to boost my immune system. I want to make sure that I'm healthy, that my body can defend against viruses and bacteria and pathogens and other things that are coming into my body to try to make me sick, right? So when we look at the immune system, we can see that the immune system is basically a response to a stimulus that's a foreign threat to the body. So your immune system has to attack the foreign threat and neutralize it. So in your body, you have like an army of cells that are constantly going around and battling against the attacks. In the process of dealing with this, the body becomes inflamed, right? So the inflammation that we talk about, it's part of the body's mobilizing of this defense force. So just like with the LDL cholesterol and the analogy of the firefighters, we're seeing the same sort of thing here, which is where inflammation is definitely a negative thing, but we're seeing inflammation due to the body mobilizing this defense force because there's an issue in that location. And then while the body's dealing with that issue, what we're seeing in the scene of the crime or the scene of the issue is inflammation in that area, right? But it doesn't mean that this is the direct cause of the inflammation. It's just that we're seeing inflammation when our body is mobilizing the defense force, right? So your body, through a series of chemical reactions, takes these macrophages in your body, which are like your body's military, and it sends them to go envelop a virus and kill it. So in order for the macrophages to go and do that, they need fuel, right? They need a type of energy so that they can go and do their job, right? And that fuel is vitamin D. So basically what happens is that it's an antimicrobial protein, and that antimicrobial protein is literally like little cannons that they go around and they surround the bacterial wall or the virus and they blow it up, they kill it. So if you have deficient levels of vitamin D, that can mean that your body is not giving the military of your body the fuel it needs to go and surround these viruses and bacteria and kill them. So just logically imagining you have all these threats in different areas of the body, or you have a virus or bacteria that comes in, and now your body recognizes it. So the alarm goes off, the warning goes. So your body wants to eliminate the virus or the bacteria before it can, let's say, drill through the cell wall into the cell and corrupt that cell and begin to multiply, or let's say corrupt that cell and then make you sick even, right? So there's a point from which this enters your body, in which, like, the bacteria, the virus, and then a point in which it infects you. So between the point of entering an infection, there's an opportunity for this military of your body to go out and blow up and destroy this virus or bacteria that's potentially going to infect you or harm you. But without adequate levels of vitamin D, now you don't have, you could even use the analogy of, like, there's no gasoline in the cars to take the police to the crime scene. So now there are murders just happening everywhere because you can't send the police there to deal with it. So when you look at that value, right, in regards to immune system, and with everything that's been going on with COVID and everything in the past, you would see that in regards to avoiding getting sick, like, I can do all the right things, but if I don't have enough vitamin D, then the chances of me getting sick are a lot higher than if I have adequate amounts of vitamin D. Because when that virus or bacteria does come and infect me, I have the adequate fuel to fuel the military of my body, to send them out to go and destroy it before it can corrupt my body. So it's so important to have vitamin D. You could even say that what good is being healthy if you're going to get a virus or a bacteria or something, you're going to get sick in some sort of way from an outside thing that was avoidable if you had the proper immune function to defeat that before it infected you. And now you get sick and you're bedridden, or Lord forbid you die, right? What good was all the other things you were doing for your health, working out, eating the right types of foods, doing the things that you needed to do? You have the vitamin A, you have vitamin K, you're working out, you're taking in the B vitamins, you're cutting back the things that cause inflammation, you're doing all the right things that you need to do, but you don't have enough vitamin D. So when you get sick, everything goes out the window, right? As well as all of those other functions that need vitamin D are no longer going to be able to perform optimally because you don't have enough vitamin D in the body. When I pull open the effects of vitamin D on macrophages, hyperinflammation response in the lungs, COVID-19 patients. So vitamin D regulates homeostasis, antimicrobial response, and inflammation. The vitamin D receptors are expressed in the macrophages and other immune cells, regulating the transcription of many different genes, including those coding the antimicrobial peptides. One of the most severe complications of the SARS-CoV-2 infection is the acute respiratory distress syndrome, caused by the hyperinflammatory response, commonly called a cytokine storm, of the lung macrophages. Studies show that vitamin D deficiency increased the severity of the acute respiratory distress syndrome in COVID-19 infection. We discuss here how the vitamin D supplementation may influence macrophage and myeloid-derived suppressor cells inflammatory response, subdue the hyperinflammation response, and lessen the acute respiratory distress syndrome in COVID-19 patients. So in this paper, we can look into that as well as vitamin D in the immune system. It is now clear that vitamin D has an important role in addition to its classical effects on calcium and bone homeostasis, as vitamin D receptor is expressed on immune cells, B cell, T cells, and antigen presenting cells, and these immunological cells are all capable of synthesizing the active vitamin D metabolite. Vitamin D has the capability of acting in an autocrine manner in a local immunological milieu. Vitamin D can modulate the innate and adaptive immune responses. Deficiency in vitamin D is associated with increased autoimmunity and increased susceptibility to infection, as immune cells in autoimmune diseases are responsive to the ameliorative effect of vitamin D. The beneficial effects of supplementing vitamin D deficient individuals with autoimmune diseases may extend beyond the effects of bone and calcium homeostasis. So this is just basically following up on what I was just saying. So this paper here that goes further into it, I have to pay $40 for it. So what I found was, I found a beautiful clip from a doctor named Dr. Rhonda Patrick, who is going to basically pull open this study and elaborate for us on what I was just speaking about in regards to the effect of vitamin D on the immune system.
May explain why approximately 70% of the US has what is called vitamin D insufficiency, while a further 28% has a low enough level to be called deficient. According to the Endocrine Society, blood levels of 25-hydroxy vitamin D below 20 nanograms per milliliter is considered deficient, and less than 30 nanograms per milliliter is considered insufficient. A meta-analysis of 25 randomized controlled trials has found that vitamin D supplementation can decrease respiratory tract infections by more than 50% in people with vitamin D deficiency and by 10% in people that were already vitamin D sufficient. So vitamin D plays an important role in activating the innate immune system. Immune cells have vitamin D receptors. Vitamin D activates the innate immune system, which elicits an early antiviral response. Vitamin D binds to the receptors on neutrophils, macrophages, and natural killer cells and stimulates them to produce microbial peptides that have antiviral activity. Natural killer cells are able to induce lysis of virus-infected cells.
So basically exactly what I was just saying with the killer cells, the macrophages, what she's basically elaborating on, what this study is basically elaborating on, is what I was saying about before, which is that the vitamin D becomes the fuel for the body's military force that's going to go to the place where the bacteria or the virus is and blow it up. That's basically what she's elaborating on in so many words. So the last thing that we can talk about with vitamin D now is supplementation and dosages. That's the last thing to touch on. So what we really want to figure out first is, will we or will we not be able to get an adequate amount through our food? So we can determine that we will not be able to get an adequate amount from the food. So the way we have to look at vitamin D is we got to look similarly at the ancestral diet. Not necessarily the ancestral diet, sorry, I should say, is the ancestral lifestyle. So when we look at the people, our grandparents, our great-grandparents, our great-great-grandparents, how society was living prior to the current time we're in today, we would have been outside in the sun for hours per day, every day, during all the seasons of the year. Vitamin D was never really an issue in the past because we had to be outside. Even when people were trying to avoid the sun, they'd still have much more sun exposure on a daily basis than the average person would today. This is why when you never get any sun and then you go outside for a whole day without sunscreen in July, you burn and you think that you need sunscreen. If you're getting sunlight daily throughout the year, because you have to, as the UV index increases through the months of April, May, and June, you're adjusting to it daily. Not only that, you're absorbing a percentage every single day, increasing melanin intake, increasing vitamin D absorption as the months are heating up, as the UV is increasing, as the amount of capacity to take in increases as well, right? So if you were hypothetically outside every day from April to June, even a few hours a day, you would have a base, and then when the UV is at its highest, your body is acclimated and it's able to deal with it, right? Which you're just saying. In climates that have winter, how it would work is that our vitamin D storage would be depleted during the winter months, and then when spring and summer comes around, that's when we would refill our storage. So our body absorbs it from the sun to be used in the colder, darker months when we are in a climate that has all four seasons. Most people do not build up enough in the summer months to have adequate levels during the winter. So supplementation for 99% of people in the winter months is recommended. So as she was saying at the beginning of this video, in most people, vitamin D deficiency and insufficiency among US adults
May explain why approximately 70% of the US has what is called vitamin D insufficiency,
70%.
while a further 28% has a low enough level to be called deficient. According to the endocrine.
So if I'm insufficient, I already think that that to me is deficient. Like you're just needing more. So I'm gonna go ahead and say that that's the percentage of people that are deficient, not the people that are insufficient because they don't have enough, but they have some. If you don't have enough, you don't have enough, right? So we know that it's an issue in North America, in the societies we live in today, that majority of people are deficient in vitamin D. So in regards to melanin, right, a darker skin tone stops you from burning from the rays of the sun. So in a tropical climate, you need lots of melanin in your skin to keep the UVB radiation down. But if you're not in a climate that would require the melanin to protect you, so you're living in like a northern latitude, you'll have a harder time of making enough vitamin D and a higher chance that you'll have a deficiency because your body is acclimated to a climate that you're not currently living in. So what would help you in the tropical climate, a necessity you could say, doesn't necessarily benefit you in Toronto and Canada because with the higher melanin, you're not getting a lot of vitamin D anyways, but that amount of melanin is now hindering you because you're in a different climate. So if you do have a darker skin complexion, it's even more something to be recommended to you to get your levels checked to try to supplement if possible. So how much vitamin D do we need? That's a key question, right? How much do we need? So 1 to 3 hours of sun per day in the peak months, the April to September time, I would say in most climates is adequate amount, right? So if you live in somewhere it's like Cuba, Mexico, you don't have to obviously apply those months because you'll have adequate sun all throughout the year. But mainly for majority of people where they live, 1 to 3 hours per day is needed. The peak time is between 10 a.m. and 4 to absorb vitamin D. In 3 hours, you can absorb upwards of 200,000 IUs from the sun in peak season. So 1 hour in the sun per day will give you more than enough vitamin D than probably a month's worth of food. If you're eating foods that are high in vitamin D, you won't be able to get enough IUs from that food that you could get in 1 hour from being out in the sun, right? So that's extremely important to understand, is that we cannot attack this from a diet perspective. We have to either look at the sun and then say, okay, if I'm not able to be in the sun an hour a day between 10 and 4, then I'm not going to be able to get enough vitamin D, simple as. So that's going to be something I'm going to need to supplement. If you're able to do it in the summer months, right, let's say between April and end of September, you can get an hour a day. You can get an hour or 2 hours every other day, for an example. You're looking at what you're doing and you're saying, okay, I think that I can possibly get an adequate amount here. I don't want to spend the extra money on the supplement. I'm going to go and I'm going to make sure that this is a priority. I'm going to get in the sun. Then maybe you don't need to supplement it, right? But then come wintertime, the chances of you having a high enough storage through the summer months, accumulation of vitamin D to stretch right through the winter, that if you do get sick or if you do get a virus or infection or if something does come up, you're not at that peak level. So how are you going to fight off that virus or bacteria? Or if not even that way, if you don't even want to look at it that way, you could just say that I'm not giving myself the greatest chance, the most optimal opportunity to fend off that virus or bacteria. If my levels are 20% depleted from what they would be in the summer and I get sick or something tries to attack me inside, I want that extra 20%. I don't want to be deficient in that, right? So in the winter months, that's when we'll look at more of the supplementation. In regards to how much do we supplement, I would say that 10,000 IUs in the winter when you're not getting enough sun, for me, is what I recommend. You can look at different recommendations. We can see different people's opinions, different studies, but from what I'm seeing, I think that especially for the majority of people who are already deficient, like if you're outside 5-6 hours a day in the sun between April and October, then maybe you don't need 10,000 IU a day every day for the whole winter. Maybe you're one of those people that doesn't need that much. But for the majority of people that are in an office, in their car, the only sun exposure they have is their hands and their face. That's the only skin they're getting out in the sun. And that's during the summer months. Never mind in the winter, people are barely getting any sun. majority of people should look at supplementing, especially in the winter months. Okay, so the last thing I want to show you here is this study here, the big vitamin D mistake. So what we're going to see here is that a statistical error in the estimation of the recommended dietary allowance, RDA, for vitamin D was recently discovered. In a correct analysis of the data used by the Institute of Medicine, it was found that 8,895 IU daily was needed for 97.5% of individuals to achieve values greater than 50 nanomoles. Another study confirmed that 6,201 IU daily was needed to achieve 75 nanomoles, and 9,122 IU daily was needed to reach 100 nanomoles. The largest meta-analysis ever conducted of studies published between 1966 and 2013 showed that 25 hydrovitamin D levels less than 75 nanomoles may be too low for safety and associated with higher all-cause mortality, demolishing the previous presumed U-shaped curve of mortality associated with vitamin D levels. So then it says here, this could lead to a recommendation of 1,000 IU for children 1 year on an enriched formula, or 1,500 IU for breastfeeding children older than 6 months, 3,000 IU for children greater than 1 year of age, and around 8,000 IU for young adults and thereafter. Actions are urgently needed to protect the global population from vitamin D deficiency. Urgently needed. It's funny when you read things like that and then you think about how you've never heard anyone tell you that this is urgent. You know, like, it's, you'd think that this would be something that would be more commonly spoken about, especially considering the last 2 years we've had, considering the pandemic and everything that's escalated from it, right? We touched on the immune system and it's great, and vitamin D's great impact on the immune system and how significant a deficiency is on the immune system and how detrimental that can be to your health if you are being attacked by a virus or bacteria. And now we're reading here that we need approximately 8,000 IU for young adults and thereafter. When we look at the supplementation recommendation on the supplement, it says 2,000 IU, right? When we look at the RDA, it's nowhere near 8,000 IU. So this study is showing that obviously there was a mistake with the IU and that people should be aiming more for 8,000 IU for young adults. So you can obviously see that, just returning back to the ancestral situation, just to wrap this video up, we can see that if we were living a regular life 80 years ago, 100 years ago, whatever the case may be, it would have been impossible for us not to get adequate vitamin D levels, right? It would have just been part of the natural cycle of life. We would have woken up every day and lived our lives, and through the months that were the optimal months, we would absorb and store vitamin D in our fat cells, and through the non-optimal months, we would exhaust and utilize our storage, replenishing it in the summer months, right? So this all happened naturally. It was never something that was needed to be brought to anyone's attention. But we could see now that with our current lifestyles, we're never outside at all. Like, even if you were going to the office, you wake up, you go outside your house, you walk from the house to the car, you get in the car, you go from the car to the office, then when you're done, you go from the office to the car, and it's already after 4 o'clock and the optimal time's over. Even if you're one of those people that smokes, you go outside, you have a smoke, even if it takes you 7 minutes to have a smoke, you're smoking 5 smokes in that time. It's 30 minutes. That's not even a good perspective, because like, who's encouraging smoking, right? Obviously not. That's not a good idea. But regardless, if you look at anyone, really, like the people you know or you think about or yourself, how much vitamin D are you really getting from the sun? And if you're not getting outside for at least an hour a day in the optimal months, then it's definitely something to look at supplementation. And if you are not going to be supplementing it in the winter, or in the summer, sorry, I highly recommend you supplement in the winter. If you're going to roll a dice in the summer and you're going to say, you know what, I'm going to get out there, I'm going to sit outside for an hour a day, I'm going to do my best to get the vitamin D, and if I don't, then I'll supplement once or twice here and there as I need, but I'm going to make it my main concern to try to get this through the sun. I highly recommend that. Like, as we were saying, you can absorb up to 200,000 IUs in 2-3 hours in a peak sun season during the correct hours of 10 to 4. You're never going to supplement 200,000 IUs. So it's not that we encourage supplementation. It's just that we don't see a clear path to victory with the sun aspect, because I just can't tell 99% of people that they need to get an hour of sunlight a day. And that's minimum, right? If you're trying to accumulate storage to be able to have all through the winter, and then when you come out of the winter, your levels are not so depleted like to the ground, you still actually have some left, that would take more than an hour a day in the summer months. So with that being said, this is the vitamin D video. If you have any questions or concerns, please don't hesitate to reach out to me. If you want these studies or you want to discuss anything further, just shoot me an email and we can discuss anything that you'd like. Have a great day, and I'll see you on the next one.